Good afternoon, dear students. How are you all? I hope everybody is fine and doing their studies. Today I brought the revision lecture on the topic refractories of your Unit 3. Refractory are those materials which are used under a high temperature and under heavy load. So in this lecture, we are going to revise the introduction of the refractory materials. What are the characteristics of a good refractory? Many kinds of the refractories are there, so we can understand it in the classification. So, classification of the refractory materials and what are the raw materials used for the manufacturing of refractory materials. What is the learning outcome of this lecture? You are going to revise the refractory material again by their introduction, the various characteristics which is required in use of these materials, classification, because on the basis of that only we can use these materials in the applications, and what are the raw materials required for the refractories. So let's start. What are refractory materials? These are the inorganic materials. Inorganic means which is not having carbon content. So these are the inorganic materials which can withstand under very high temperature without undergoing softening, melting or deforming. Means no change in the dimensions. Deformation means no change in the dimension, means size, shape. Understood? So softening has the melting, means change the phase, as well as change in the size, shape. It doesn't happen under high temperature, under high load. These materials are called refractory materials. It should serve as the structural material under the service conditions. Structured materials means when we are going to use that materials where we go for heating it under high temperature. So there in the construction only these materials are used. It should contain the mechanical functions at the high temperature. Means it should maintain that temperature of working, of operating, where we are making the reactions or when we are going to change into some other products. So that temperature should be maintained. Refractory materials are widely used in providing the high temperature resistant like lining for the furnaces where the material are to be heated at the high temperature. As you are able to see in the diagram, this is a furnace in which the circular we have the lining of the refractory materials. So this is a very important application of the refractory. The kilns are also the ovens where we go for burning out the materials. So at that temperature, we also use the refractory material lining. And here you are able to see these refractory material bricks. These bricks are prepared, which in the form of bricks it is used. for the lining purpose. And as well as it is used in the ladles. In the third diagram, you are able to see here, it is the shape, specific shape, the ladle which is used for refining purpose. Understood? When we are going to for the process of the refining of the steel and other materials, they are to be used in the specific shape container, and in that we use the refractory materials. So many applications are there for the refractory materials. In the actual service conditions, the technical utility of the refractory depends on the properties and the behavior of the refractory along with the probably occurring destructive conditions. Means the service condition we are using the refractory material or the application, it depends on the property of the material, means which kind of the refractory you have selected for that application, what are their properties, their behavior, as well as the condition, external conditions or the destructive conditions if it is having, it depends on that. So we cannot say only the material type and the property it depends, but the condition should also be checked when we are using these materials. Now we see what are the characteristics of good refractory. Means in the application, what are the characteristics required? There should be no substantial change in the physical, chemical as well as mechanical properties under service conditions. It is very important point, means when we are using these material in application, their physical property means their size, shape, dimension, even though its chemical properties, mean it should not go for the reaction or somewhere the chemical raw material which is there in the refractory goes of changing to the another product. That should not happen. So physical properties, chemical properties as well as their mechanical properties. Mechanical properties means when we go for seeing its hardness or the strength wise, that should also not change under service condition. The second important characteristic, it should withstand under high load. It is very important. It should bear the load, means how much load you are giving to a furnace. There the lining of the refractory are there. It should bear that load at that working temperature and other severe conditions. Suppose the conditions are not favorable. So at that conditions it can bear the up to that temperature where we are using it, that is working temperature, and the load should be bared by the refractory. The next characteristic is it should not show cracking, pitting, splitting and flaking of the furnace. Means the furnace should not destroyed by having the lining of the refractory materials, like cracking occurs or splitting, flaking. It can occur such kind of process in the furnace, or the holes or the pores it can create under service condition. It should not create such conditions. So a good refractory should minimize these conditions. It should not react with the corrosive substances such as acidic or the basic molten slags. Sometimes when we go for heating, the gases are produced and the liquids are produced, and we have the extra materials there. So it should not react with such kind of the substances. including acidic, basic as well as hot gases. It should be chemically inert under service condition. Understood? So the reaction should not take place. It should be inert in all the conditions when we are using such of the refractory in the application. The next characteristic is it should possesses the good resistance to the abrasion by the dusty gases as well as erosion by the molten metals. So any kind of the having dusty gases arises in the heating, it has the good resistance to bear it up, as well as the molten metal which is producing, that is also, it should be having a good resistance in that erosion of the molten metals. The next characteristic is it should possesses low permeability. It is an important characteristic. It should have the less number of pores. Because of that, it is having the less permeability. Low pores causes the less diffusion of the gases and the liquids inside the refractory material. So if diffusion is more, the gases can easily pass through the refractory material, it can damage it. So less number of pores, less diffusion causes, it should be low permeable so that the refractory materials are not destroyed. And if it is not destroyed, it can protect the furnace. It should possesses the good thermal strength. Understood? That is the up to a desired temperature, it is having the stability. It should withstand the thermal shocks also. Sometimes the sudden change in the temperature occurs. For the change in the temperature, it should also bear and have that change due to the rapid temperature fluctuations. Sometimes the shocks are there. So it is very necessary in that shock the resistant properties are good of the refractory and no damage occurs. Now we see the classification of the refractory materials. On the basis of the materials required to prepare the refractory materials, we can classify the refractory materials into three types: the acid refractories, basic refractories, and the neutral refractory materials. So first we are taking the acid refractories. What are the acid refractories? It consists of the acidic materials. The acid refractories are made up of the acid materials like alumina, like silica. Okay. So alumina based refractory, silica based refractory, fire clay refractories are the acid refractories. They are not attacked by the acid materials. They are more resistant to the acid materials. But it can easily attack by the basic materials. Okay, because they are made up of the acid materials, they are more resistant to the acid materials. But they can easily react with the basic materials. These refractory materials are also resistant to the slags that are rich in the silica and are often used as the containment vessel for them. Okay, so they are more resistant to the acidic slags. So where we are using the acidic materials in the application, it is required to use the acid refractory. On the other hand, they are readily attached to the slag composed of the high proportion of calcium oxide and the magnesium oxide, and contact with these oxides should be avoided. Means these refractory material attacked by these basic material. These are the basic material, calcium oxide and magnesium oxide. So It readily goes for attacking these materials, and it should be avoided to have such contact with the basic materials. Now the next is basic refractories. These are those refractories which consist of basic materials or which are prepared by the basic material. For example, we have seen some of the basic materials, that is calcium oxide, magnesium oxide. Understood? So the materials, for the basic materials, we are going to prepare the refractories. They are called basic refractories, and they are more resistant to the basic material used in the application. So these are not attacked by the basic materials, but easily attacked by the slags and the acidic materials. So it should be avoided the contact of the basic refractory to the acidic materials. The example of the basic refractories are magnesite and dolomite, having calcium oxide and magnesium oxide materials. Now the third category is the neutral refractories, and they are made up of slightly acidic and the slightly basic materials. Understood? So they are not totally acidic or totally basic. They are having slight acidic and slight basic materials to prepare out. We have various examples of the neutral refractories. Contain the carbon, chromite. The main raw materials are these: carbon, chromite. Chromite is FeO.Cr2O3. Zirconia, it is ZrO2. Carborundum, it's a famous example of the neutral refractory, that is silicon carbide. Carborundum is the silicon carbide. Understood? The graphite is also the neutral refractory containing carbon. So these are the examples of the neutral refractories. So you have seen three types of the refractory on the basis of the material which is used to prepare it. Now let's see what are the raw materials required for the manufacturing of the refractory materials. The refractories materials are obtained from ores of silica or alumina. If we just want to prepare, silica and alumina are the raw materials which are acidic in nature, and they go for just ores of the silica after coming from the mining process or the chemical production, as well as calcining the materials. These materials are crushed out, grounded, and prepared to the appropriate size. So where from the silica and the alumina comes from? It comes from the mining process. Either we are extracting through the calcination. This is the extraction process. So they are crushed after the extraction and then grounded and prepared to the appropriate size. They are then mixed with the other materials and shaped as a bricks. Understood? If we want pure strength, they are mixed with the two or more proportion to the other materials, so that, and it can be shaped as the brick form. We have seen the brick diagram. Bricks are used for lining, melting, and other furnaces. So mainly it is used in the shape of the bricks, as you have seen in the lining of the furnaces or the kilns. So bricks of the acid and the basic and neutral refractories are of different shapes, and it is available for the furnace construction. And this how the refractories are prepared. So First of all, the raw materials which are to be taken in the form of ore, and then extraction takes place, then it is crushed to the appropriate size, mixed with the other material and shaped it in the form of bricks. And if we are having the acidic material, we prepare the acid refractory, basic materials, basic refractories, and finally the slightly acid and slightly basic come up with the neutral refractories. So we have seen in this lecture the what are the refractory materials, then what are the characteristics involved, what is the classification of the refractory materials, and how they are prepared by using the raw materials, and raw materials are come up from in the form of ores. In the next lecture, we are going to revise the properties of the refractories. Thank you and take care.